In this presentation, we're going to look at the conditional probability formula, and we're going to do something a little bit interesting. So what we have here is two events, A and B, and we're told two pieces of information about these events. The probability of A is 0.3, and the probability of A intersection B is equal to 0.1. Okay, so that's sort of a fixed number. Now, so the question is, find the minimum value, possible value of A intersection B. That's really the question we're asked. And what we're going to do is use the conditional probability formula for that. That's probability of A given B equals to the probability of A intersection B, or A and B, divided by the probability of B. And we already know what that is. That is 0.1. So essentially a big question here, it relates to PB. And how that would further impact the probability of A given B. Okay, so just to sort of start us off on two key points there, just to sort of get us started on our journey, we'll just actually consider this first off. The probability of A union B, the minimum and maximum value of that. Okay, from that, what we can deduce is the probability of B, what the minimum and maximum possible values of that would be correspondingly. So we just go in stages here. So the probability of A union B, the maximum value for that is simply 1. Okay? Oops, P. That's just sort of relying on the fundamental rules of probability there, that a probability value can take any value between 0 and 1. Okay? So we're not given any information to contradict that maximum. Now, what is the minimum? Well, let's just have a quick look at a Venn diagram here. Okay? So this circle here would correspond to A, and that one would correspond to B, and it's this shaded region here is the probability of A, and the shaded region with the pink shaded region and the yellow shaded region is A union B. Okay, so it's both components there. Okay, now we're told that this is 0.3. Okay, so the shaded region must have at least a probability of 0.3. So the rest of it could be 0, or it could be 0.7. But that means that the minimum possible value, let's go back down here, the minimum possible value of A union B is 0.3. Okay, so what we're going to do here now is sort of see how this relates to the probability of B. And what we're going to do here is use this addition rule here. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. Now, in both cases, the probability of A intersection B is 0.1, and likewise 0.3 for the probability of A. So the minimum possible value for A union B is 0.3. The maximum possible value is 1. So essentially in both cases, if we were to work it out, deduce in both cases, work it out, what the probability of B would be, the minimum possible value and the maximum possible value, we find very quickly that the minimum is 0.1 and the maximum is 0.8. Okay? So just actually to remark again here, I didn't mean to do that, but that was sort of helpful. The probability of A intersection B is a constant. So that is 0.1 in both cases. So the minimum value of the minimum value is 0.8, okay, and the maximum value is 1, okay. So yeah, no, so essentially this is the maximum probability of B, which actually corresponds to the minimum conditional probability of A. But essentially, that doesn't matter too much. Okay, just to sort of remark that this is actually the maximum value of B there. So what the roles of the minimum and maximum sort of switch around a bit. Anyway, so the minimum possible value for A given B is 0.2 or 125, and the maximum possible value there is 1. Okay, that's grand. We'll leave that there.